Before coding Websocket asynchronous application, I want to talk about the differences between the synchronous application and asynchronous applications, because there is no point if you don't understand what is asynchronous applications. There's no point to write the code, because it says all the APIs are given by the library or the Boost, or by the framework. So all things handled by the operating system. But we should understand the difference and the advantages of the asynchronous applications. So it's a good idea to talk differences between the synchronous applications and asynchronous applications. First, I'm gonna try really easy way, in an abstract way, to explain. Then we will jump with the Boost. I will show you a few website that you can also read. We will check together. Then we will just jump to directly coding. So let's think first how synchronous applications work. Like synchronous application is a sequential applications. When you write the code line by line, all lines handled by sequentially, all lines handled sequentially, right? So this is synchronous applications. All lines depends on each other, For example, let's talk about the hardware. Let's think the hardware. In the hardware we have cores. Each core has one hardware thread, and the operating system can have many threads than the hardware. So let's think we have one core. Okay, we know that we have a lot of cores in our modern computers, but let's think right now we have only one core. And also in the operating system we have only one core, okay, one thread. So I just want to make all things simple. Then let's say that this rectangle is a core or thread or core. We have one thread. In this example, in this abstracted example, one core means one thread, let's say, to explain the things easily. Then the core process the task, let's say. Task can be the function or the program or something else, I don't know. Okay, it doesn't matter right now. So core process the task. And in this sequential way, in the synchronous way, when core process a task, then it can jump to another task, right? So the core has to wait to finish the first task, to jump the second task, or so on. The tasks are dependent each other. If you want to process the second task, first you should finish the first task. Even if, for example, in the middle of the first task there is a sleep. I don't know, just a normal sleep or just waiting for socket, but we know that we will sleep there. Okay, so even if this case, for the synchronous applications, you have to wait to finish this sleep. You have to wait for nothing, right? This is just a sleep. When you want to, even if, for example, let's think this again, the sleep case. In the first task, there is a sleep. So the core start to process a task and come to sleep and sleep there and finish the first task, then jump to second task and so on. Let's see now how this thing works in the asynchronous way. So let's think we have an hardware or an operating system which handles the processes in an asynchronous way. Okay, and we say that, okay, work in asynchronous way. Process the tasks asynchronously. So core start to process that first task and come to the sleep. Then we know that we have constant time there. The operating system knows. So it can jump the second task. It doesn't have to wait to finish the first task because we know we will sleep there. We don't have to wait. So then process the second task or as much as possible, then come back again the first task. When the sleep finishes, then continue the first task to finish, and so on for the other tasks. That is it. That is the difference between the synchronous way and the asynchronous way. So let's see now in the Boost what they say about this and how Boost handle the asynchronous operations. But also before start, I told you, now we have one core one thread, but that doesn't mean you have to use one thread this as in the asynchronous way. You can use multiple threads. If you check std async, they say potentially in a separate thread. So it says that when you call the async std async, it will throw a thread. So as I told you, we can do this asynchronous behavior with single thread, right? But as you see here, for each std async operations in C++, it says potentially in a separate thread. It can throw a thread. I tried this in different environments with the, I think it depends also the compiler. I saw this throw every time in another thread. So what I'm saying is you don't have to worry about this. I mean, you can have one thread or more, okay? That doesn't mean if you have one thread, if you, for example, if you have one thread, that doesn't mean you cannot do asynchronous operations. You cannot create asynchronous operations, applications. It doesn't mean. It's up to the framework or C++ or library or something else. You have to check, or operating system. There are a lot of parameters. So here, it says you can find these links below the video. Don't worry about this. They draw some diagrams to explain the difference between synchronous operations and asynchronous operations. You can read all this, but I just want to explain a little bit. I don't want to read by line. So in the synchronous operations, as you see, this is your program. There is a socket. Your program opens a socket. This is about the boost. So socket go to the IO context, right? IO context, we know the IO context is a layer between the operating system and your applications. And IO context goes to the operating system. Operating system goes back to the IO context. IO context goes back to socket, and the socket and to your program. Then you see that the socket application is working well, or if there is any problem. So this is the way to pass. But this, as you see, that this is just a sequential way. This is what we know. This is the easy way, right? It's all sequential. It's all layers, all steps depend each other right here. So let's check with let's check the asynchronous way here. When you check the first time, you see that there is another layer, another box here, completion handler. So this is the point for the asynchronous operations in the boost. So let's check the arrow by arrow again. So your program here goes to socket, and socket goes to the IO context. IO context goes to operating system. There is another drawing here we should check. Then operating system goes to IO context. So this is different. This is what says that operating systems handle all asynchronous operations. When the operating system is ready to handle this asynchronous function you pass, then it will call the completion handler. So completion handler is a function or a lambda expressions or something that when you want to call asynchronously, this completion handler will be called. You pass this completion handler to asynchronous function or API, then this will be called when operating system is ready or not. So if you check here the requirements on asynchronous operations, it says this sentence is nice. You need an initiating function and completion handler. Just two of them. So what is initiating function? Initiating function simply is async accept, for example here. We will use acceptor, acceptor we use in the part 1. Here for probably, async accept. We use this accept in the part 1, to create this synchronous application. Also, it's a good idea to also watch the part 1. You will understand better. This async accept is initiating function here. Then this lambda expression is the completion handler. They also call this a token. So we can pass here also the function, no problem. But I'm going to use some lambda expressions. That is it actually for here. But if you check here, this function, this initiating function, returns here. There is no content for it. So this is important. What we should understand here, Asynchronous operations, asynchronous functions return immediately. This is an important sentence. You can find this sentence in the internet very much. When I first, when I saw this first time, that I didn't understand. What does mean returning immediately? So there should be a content in the function, right? So that is the point. So you just pass your lambda expression to the async accept function. Then async accept function return immediately. Your compilation handler, your lambda expression, your function, goes to the queue if operating system is ready. Then if everything is well, IO context handle this, call this function. That is it. You don't have to do anything. You don't have to worry about anything. This is the difference for also the boost. This is the way how boost handle the operating. This is the way for the boost how it handles the asynchronous operations. It is also a good idea to say in the beginning, asynchronous operations is not a better every time, than the synchronous operations. It depends. If you have more data, to handle, function to handle, for example, streaming a video or some HTTP operations, Websocket streaming, for example, then asynchronous operations, asynchronous function is nice, is better. But if you don't have, then synchronous one is probably same or better. But also this, okay, I'm going to write an example, but you think that it's really, there can be a complex situation and there can be a problem. So then if you're working with the asynchronous operations, to find the problem is not easy because, you cannot handle this. The operating system will handle this. So finding a problem can be quite, hard with the asynchronous operations. We will not see any problem now because we will write some simple echo server, WebSocket server. So also this is important to say. Okay, so let's start coding. Before start coding, let's check first UML implementation, UML design. So there will be a echo WebSocket class, and there will be listener class. Listener class will use the echo WebSocket. This will be implemented, this will be created in the main part. So each class will be inherit the enable shared from this. I will explain what is it. Because we are using the shared pointer, to return to return at this pointer, to not return the row one with the shared pointer because of the ownership problems. You have to inherit from this, enable shared from this. But yeah, I will explain it. This is a simple way. This is a simple representation. Okay, let's start. I have simple here. I just include the related needed libraries here. Boost, the core HPP, and the WebSocket HPP. And these are the namespaces that I just took from the internet. The example in the Boost website. This example is actually derived from this example which is in the internet, which is in the Boost library, which is Boost GitHub repository. It's quite same, but I just use more, with the lambda expressions, nothing more. Quite same. So you can use it also, the one which is in the GitHub repository. This will be the local echo server actually. So that is why I just write here the port number, right? So I will not define the IP address because it's a local one, 127 and blah blah blah. So let's start first to implement the listener class. Class listener. I'm not good at giving the names to class, but you can change. You can give whatever you want. It doesn't matter. Which simply creates the server within an asynchronous way for the socket application, and this socket will be passed to the WebSocket class, which is the echo WebSocket class. Then there will be, as I told you from the image from the UML diagram, we will have private variables, which the first one actually the IO context. I told you, right, this IO context is the abstraction layer between the operating system. So when you open a socket, when you create a timer, or when you use some kind of an hardware related stuff, you have to create IO context because it it will make your program portable in a Boost way. You know, you can run this program in the also Windows, but I am using this in the Linux side right now. Also, by the way, I forget to tell, I'm using this version 1.71 for the Boost in the Ubuntu. So this can, for the lower versions, maybe this will not work, this example. So please stay in this version or the highest one. You can check the version like this with the DP, you know, key G -S. This is the libboost dev. You know, if you check the first part, then I showed you how you can install the Boost with the, you know, apt-get in the repository, from the repository, or, you know, with the package manager, I mean. So we will have IO context. Of course, we will directly pass this IO context with the, you know, reference, not copying. And also we have acceptor. As I told you, acceptor class has, you know, the methods for asynchronous operations, synchronous operations, for other things. So we will call the async accept from this acceptor. Acceptor. I don't care the notations or names, you know, I don't care. I don't focus these things now. I just focus the functionality and to understand how we can use the asynchronous operation. So don't worry about the names and, you know, notations. So we will have a public constructor, listener, which actually will have the IO context to, you know, pass our private variable IO context IOC. Let's give the same name, and that should be the port. So unsigned, it should be, I think, unsigned short. I'm not sure, we can check, no problem. The compiler will tell us. Then we will simply assign our private variable with this. I gave the same name. It's not a nice idea, but I know, but whatever, it will work. Then we will assign the acceptor. I will do like this. Acceptor. IO context. I think there are a few way to implement it, but I'm using this way. So I will going to pass here the IP address and the port number. So net IP make address, which is the endpoint actually, right? This will take a string, as you see here, 127.0.0.1, and the port number, simply port, which will here 8083. I will leave this constructor empty, but for the endpoint, you should check this port number is okay, the IP address is okay, the binding operations is okay. You have to check this, okay? But I'm not doing this because I know this port is now ready to use. 8083 port is open now. I know it's my local area, and so the local IP address is working, I know, so no problem. I want to keep it simple to explain it, right? But normally you have to do this, and it's explained also in the website. Don't worry, it is quite easy. Then we will have void function, which is, let's call it async. Let's use camel notation for this, the name, async accept. This function will create the asynchronous socket operation, and which will call the Websocket class that we will implement in the next. So simply let's use acceptor and use the async accept. Okay, if you check but we can check it later. For the Websocket we can check. So we will pass here for the IO context and here the lambda expression. You can pass here also if you want normal function, but I'm going to use like that. So that is it. As you see, as I told you, async accept. See here, there is no content. I mean, there is no content like this for the function. We are not writing anything here. See, the function is empty. The content is empty. As I told you, asynchronous functions return immediately. We will create content for this, for the compilation handler, right? As I told you, or token. So this will call this lambda expression, call this async accept again. So when you create a listener and there will be a some client, so this will accept the connection. For the second client, you will call again this function like a recursively. Okay. As I told you, we use the shared pointer. So that is why we have to inherit this shared from this. But let's assume we don't know this. So I just put here this row pointer to access the async operation, right? Async accept, or let's put an ampersand. It's quite the same. So for the notation, we will write here boost system error. If I am not error code, yes, if I'm not wrong, you can check with the compiler. And TCP socket, let's say. So this socket, as you see that we are not caring about the socket right now. This socket we will pass to echo Websocket class. So it's already given for us. So we are not creating this, right? This is given by the async accept, one of the overloaded ones. You can check the other versions of the async accept function. But we can call the async accept again here, like this. So let's put some text to check, to test this. Connection accepted. Connection accepted. Let me check if there's any problem. Yeah, we have this. Oh, okay, we have to implement also here std make shared listener, and we will pass IO context and the port number, right? And we should call the async accept function to start, to accept the connections. Also, we are, I don't want to forget this. To run the async operations, to create this queue, as I told you, in the operating system or other stuff for the async operations, let's say, you have to call the run method from the IO context. Otherwise, it will not work. You will not see the events. You cannot control the async operations. So simply like this, like a thread run, thread, join. It's like a thread join. So it will block here. So it will not return. It will block and handles all the operations. You just put this in somewhere in the code. That it will nice. It will be okay. Okay, let's try to compile and see. Probably there will be some problem. So I'm using the std C++ 17, but you can use also C++ 14. I think, I'm not sure, but I like this version. Also for the list initialization implementation that we are going to use for here in the next, to directly initialize in the list in the lambda expression. It should be C++ 14 at least, 14 to use this feature. Okay, so as I told you also before in the first part, this boost and boost libraries are the header files, so you can directly include them like this. It's easy because they are header files. There is no CPP, just the declarations. They are just declarations. So you have to also bind the pthread, otherwise you will have kind of weird problems. And this is the name of my CPP file that you can change whatever you want. And this, the WebSocket async, the binary name. Yeah, there is a problem. No matching function call. Okay, I forget here the parenthesis, one parenthesis. So here also this is wrong. This should be like this. Yeah, it's my mistake. I think this should work now. Yep. So let's run the Websocket async example. As you see that I didn't create any connection, but the connections, accepted this will, call recursively. This is not what I want. So what's the problem here? As I told you this will block, right? This will block the connection. So if there's a connection, this will be called. As long as this will not called, right? Or this will not called. I mean, this will wait, right? But this is not what I want. This is the undefined behavior actually. So you can also see maybe exceptions here. It doesn't matter because now we create with the shared pointer here. We are trying to control the ownership with the shared pointer, but we are using directly references here. Or this also, if you put this here, this will give the same problem. So this is the row pointer. This is the ampersand. This is the address. This is not what what we need here. We need an ownership perspective. We need a reference or this pointer from the ownership perspective with the shared pointer. I mean, so simply we should, let me stop this. Simply we should inherit here std enable shared from this, and you should give the name the same class. So now we can, instead of this row pointer, this row keyword, we can use, for example, I just give the name self and shared from this, which will return this, but in a shared pointer way. Not exactly this, of course. Shared from this, and also parentheses. So now we should also use this way. I will put self. It's clear, right? Now in the self we have enough, let's say, enough permissions, enough ownership to call async accept with the make shared or shared pointer. This is the correct way. This is the correct usage. Right? The compiler will not give you the error if you don't use in a correct way. So you have to know it. So let's try again. Let's try to compile. Let's run. Okay. So it's waiting. It's waiting for the connection. Let's open the new terminal. So I have here a new terminal. So, and with the nc command, I can create simple connection, socket connection. We are not doing anything WebSocket right now. We are not doing anything with the WebSocket now. We just try to create the socket layer, right? Then we will jump to the WebSocket. So I'm going to try to connect to this server now. Let's see it will work or not. Localhost, you can use this command simply, and I know the port number 8083. I just gave in the main. So yeah, connection accepted. See, I think do it again. Yes, but of course there is nothing. See, I cannot send anything, or yeah, it's not working because it's not working because we haven't implemented it. We just accept the connection, nothing more. Okay, now let's start to implement the Echo WebSocket class. Then here we will call this Echo WebSocket class here, the instance. But as you see here, before start, we are using the one thread, right? If you create this IO context like this, it's empty, means one thread. If you put here 4, 5, I don't know, 6, whatever, then this will be the number of the threads that you want to run. Also, you have to run this in the for loop to run this all threads. Then we will check this later. Let's come here. So the name of the class, Echo Websocket, as I told you. Echo Websocket. So this will be also, inherits the same std enable shared from this. Otherwise, we will see the same problem. As a private variables, we have WebSocket, stream, beast, TCP, stream it should be, yes. This is the WebSocket streaming, WebSocket stream. So we need a buffer. Well, I'm going to use the flat buffer to hold the data and send it back or manipulate the data, whatever you want to do. Flat buffer. Then as a public functions, we will have the constructor again, which get the TCP socket from the listener class, as I told you right here. This socket we will pass here, pass socket to WebSocket, Echo WebSocket. We will create the WebSocket instance here and pass the socket now, but let's create first the class TCP socket. Of course, this is the forwarding, perfect forwarding, the right value, R value. I mean, we have to move it. We have to move the socket. We cannot copy it. We cannot copy the socket. And this will be the FC. Also, we will use std move, here for the socket. So we pass the socket to std move. Let's create an empty constructor. Nice, looks nice. Okay. Then we first need a run function, which will create which will initialize the async accept. Okay. Then we will call async read and async write. So vs async accept, and we will have the same notation directly like this for the lambda expressions. So again, we should use this self initialization to return the correct, to access the correct pointer, not the raw one, as I told you a few minutes ago. Shared from this, and this will be error code, just the error code for this beast. We will not see any error code now, right? So, but I have to write it, otherwise it will not accept for compilation. Then, if there is a problem, we will return it here. If EC, error code, if there's something, then let's write it. And EC message. And I don't know, okay, end line, okay. I don't like end lines much, but okay, no problem. So we will return. Okay, then here we should call self the function which will which will get the text and echo back, send back to the client. Let's call it echo. Okay, that is it. But before this, let me compile if there is any problem to see. Oh, it's still working. Nice. So let's compile the code. Yeah, of course, was not declared listener. This should be Echo WebSocket, right? That's, generally I'm doing these kind of mistakes. It's better to see early. Okay, great. Then let's start to implement the echo function. So this will be the void echo it will not take anything. We will call directly vs async read, not accept read. This will get the buffer. This is quite the same. You will not return anything. See, it will return immediately. So this needs buffer, which will filled with the coming data. Buffer and shared, like the other ones. You can put here also the functions, but I'm using the lambda for expressions. It keeps the function, for me at least, simple. But you can do it. I think for this echo, yeah, it's a good idea to create some functions, because we will put another lambda expression in the next, but whatever, let's see. Oh yeah, this will be again the same idea for the self. Then we need an error code and the size of the transferred bytes. So beast error code here. Let me do like this, and okay, let me also here. It will better to write line by line. Then, as I told you, std size t, which is the type, so bytes transferred. I hope I typed correctly. Bytes transferred. Okay. So I will come here. We should check error code again. So if you check the first video, you should understand this quickly. That if there is any connection, disconnection happened, then you should check the closed here. Then you should return. Otherwise, it will throw an exception. Then yes, let's copy this again, but don't do it. Don't copy paste. It is more potential for the errors. So if there's an error, then yeah, it will return. So now let's read what we get. Let's call an out. So beast will convert it to string, buffers to string, and self we can access with the self row. Buffer, it should be C data, character data. We can type it here, we can print it here, right? So out std, maybe we should std endline. Okay, looks nice. So let's compile this and not return back anything, right? Let's compile easily, and what we read, just type here and print here. So let's compile again. Let's see if there's any problem or not. Okay, there is no problem. I'm going to use Google Chrome. Also, I will show you some Python examples with the Websocket for a client. Okay, let's run the Websocket async. And this is the tool that I'm using, for connection. I showed you before, I think. Yeah, I tried it before, I think. So I connected, connection accepted, which is a socket connection, and also I think the WebSocket is working now. So I'm writing something here. And send, WebSocket has connected to the server. Has not connected. Because okay, I forget here to call the echo. And also we forget to call here, right? Yeah, guys, I forget it. So I forget here to implement the WebSocket. So that is why the connection is not working. So here, then let's remove this. We will use again the std shared. Make shared actually. Make shared. Echo WebSocket std move socket and we will call run. That's it. So let's compile again. I hope there are no problems. Nice. Let's run the example. And then try again. Okay, everything is okay, ready to go. And I just sent this string. Ta-da! Okay, it's working. So I can see here the text. I can send something. Why? Yeah, because okay, this is normal because just we are reading and printing once. We didn't call the echo again and again, right? So it's normal. So yes, this is what we need. This is what we did now. For the first, this is just first, this is just a single shot. We should call echo here again. So for example, what I mean, you will understand. For example, I think if I write here like this, self echo, then it will work indefinitely. Let's try. Go to tool, connect it, send this, send something more, as you see that. Yeah, but well, of course we also forget to clear the buffer. It's normal. It's just add to the end. It's normal. Okay, let's do everything and echo back what we read. Then after getting the text, we should write back, right? This is the echo server. So this will be quite same with the async read. So this will be vs, if I am correct, but of course we should access the ws with the with the self, then async write. This should be then, which will take the data, self buffer data, like that. To call asynchronously. You see, I didn't use any other functions. Just you can do this with the lambda expressions. It's more, I think for me it is more convenient. It's more better. So we need again here the self, but we can, I think we don't have to pass here or something. But I think let's pass just a self. We don't need a shared from this because also we already get from it here, right? So we don't need to pass again. So self. Then we need a beast error code here again. Then finally the same, actually the size of the transferred bytes. Looks nice. Then if there is a problem here, we should return like the previous one. And we can send the data. But actually we send it already, right? This will write the data. So we should consume here. When we, this will send the data. When we pass here, this will already send the data, but we will consume the buffer. I mean, we should clear the buffer here. So to clear it, we will actually call the consume and self buffer size. I just want to use the self here, but I think it's not a big deal. So you should call this echo here again inside this function. Okay, that is all. Let me put this also here. Yep, that is all. Let me check. We just create the async read, we get the self, and then we read the data. Then this data just pass to the async write without changing anything, same, which is echo server. You can add something to here or manipulate the data, it doesn't matter. Then we read the self again, we get the self again and read the error, and according to the yeah, we haven't used it, but this is the way. Bytes transfer, maybe we can use it here for the bytes transfer, but it's not a big deal right now. So we consume the buffer here according to the buffer size. Then we call the echo back again to send the next, to handle the next string, next message. I think everything is all right now. Let's try. Let's run the application and open the it's clear screen and open our test bench. Yeah, I think we don't need to use anything anymore. Let me show this. So we will pass something here. I can change that. No, we will pass the string here, string example string, for example, example string. Then we should see here, connect it, send it. Yes, it is send it and it reads back echo. Yes, yeah, it's working. It is working. Nice. This tool is nice for the it can be used with the Chrome applications. Also there is another application, the Postman. If you are a web developer or something, probably you are using this more than me, I think. But at the last May, I think they add the Websocket handling mechanism. You can send the Websocket messages with the Postman, so it's easy to install also the Ubuntu. Let me show you also. This is the Postman. You can find more information. I'm not an expert on this, but for the simply, you can use the Websocket application to test with this tool. It's really nice. So here, as you see, if you use the correct version, you will see the Websocket request as a beta. Yeah, this is still beta, but it's working. You can try it to test applications. So then you will see that in line here to enter your URL. I think it should work like this. Let's check. What was the port? 8083. Then connect. Yeah, it's connected now, as you see. Then we can write something, for example, like this, or yeah, hello Mars. Then send it. Yes, this is send it message. This is this is the send message. This is the echo message here. Nice. Also, you can use this. I just want to show you. This is better. Also, you can create some HTTP requests or other things. Probably it will be really helpful for you. At least it's really helpful for me until now. So let's check now how we can implement the how we can use the more than one threads. Before showing how we can use more than one threads, let me explain a little bit how you can see the thread numbers, so you can understand that you are using different threads or not. So in the Linux, I'm going to explain it in the Linux here, but also I think you couldn't do this in the Windows, but I'm not explaining anything but for the other operating systems, but it's not a big deal right now. Just I want to prove we are using the single thread for async operations. Okay, so for example, you should copy this. You should write here this, but I'm not sure this is necessary for some Linux operating systems, but no problem. You can copy it. This will return the function which will give us the thread number. So for example, we can call this inside the async write or async accept, for example, or yeah, let's put it in the read echo function. which is it's asynchronous already, so no problem. Let's put here, let's print the thread number, one of the async operations, no problem. Let's see out, and thread ID, let's put it in that way. So get ID, which will return the thread ID from the operating system perspective. Also, there is in the std library, there is an get ID for this thread, but it will give you not from the operating system. This will give you, for example, if you have 3 threads, then you will create one thread and kill another thread. For the last thread, it will give you the same. It can give you the same thread number. This is what I need. I want to see from the operating system perspective. Okay, let's see. Let's compile to be sure it's correct. Okay, let's run the application and bring the test tool here again. So connect it. As you see, it is same. Thread ID is same. So now create another one. Let's connect again. And thread ID is same. Thread ID is same. So let's check now how we can use the more than one thread. So simply we will put here, for example, how many threads you want. So just an integer, for example, just threads. I just put here 4, but let's create an int threads is 4. Pass this here. Then you should run this. Let's create another vector for it, which will hold the threads. Then we can run these threads, you know, looping the vector simply. std threads, and let's call it v. But this should be green. Why? Maybe I forget to add the std thread. I don't think I need it here, but it will be called, I think, one of these, but I'm not sure. Let's call this thread. Okay, yes, it's nice now. So we can reserve for the size. Threads -1, you know, starts from the 0. Threads -1. Then with the loop, yeah, let's do it in that way. Threads -1. I should be 0. And iterate the I. So we should add these all and place back, you know, to the vector. And with the, yeah, we can use again the lambda expression. If I can type correctly. Yes, not the correct order. So here we'll pass with the ampersand again, IO context. Then I think this can be empty, so IOC run for each threads. I think it's okay. So one more semicolon here. I think, let me check. Yeah, we didn't get anything. I think we can also remove this part, whatever. Okay, let's compile. Okay, there's no problem. Just run the application again. Let me clear the screen and go to test application, connect, send. You see that threads number are changing now. So that means we are running this async echo WebSocket application with more than one thread. See, thread IDs are changing, and we are not controlling the threads. So, but this is not thread safe. What I am doing now, maybe I am not. I'm not. Yeah, I don't see any problem here because of the maybe the tool, or it's not very complicated testing, stress testing. This is not correct way to use more than one thread. We have to make it, we have to protect the listener class. There is a strand class for this. We can use this, which will provide a serialized function invocation. Okay, this will be easy, quite easy, very easy. So what have to be done? Just we should, I think, call here the strand, include boost SIO strand HPB. Then we will only encapsulate, actually not an encapsulation, just we will call here the strand and pass to the socket. We should simply cover the IOC context with the strand. Make strand IOC like this. Then there will be no changing here. And I think also for the IOC, this is the listener part here also, which is the same. So that is it. Then this will protect from the race condition. So when you move the socket, you don't have to care about in the WebSocket anymore, because it will be already moved the strand. So that is it. It will be serialized. The function calls will be serialized. So let's check. Yeah, we cannot see the effect, I think, but at least we can see that it's working or not. So connect, send something. Okay, different threads. Connect with another client and send something. Different threads, different numbers. Yeah, this is working. This is working, no problem. So to test the asynchronous operation and the synchronous operation, I think it's not a good idea to test them, because they are two different, different things. You cannot put them in the same league. It's not possible. But let's create a way to test them. So in the first part, we create not this one. In the first part, we create some example in a simple main application, which will accept WebSocket connections, and throw a thread for each connection. So it's assume it's kind of a quite fake async operations, right? It's not an async operations, but it will throw a thread for each client, so you can handle more than one client. Okay, this is a good way. We can do it with synchronous operations also, with using threads or other things or other way for parallel communication. Let's use this to compare the asynchronous operation. Okay, so what we will test here, this I have a Python script here which use the WebSockets class, WebSockets package, let's say. So it will open also this is async. It will open the connection here and send the number, which will increment it to 10,000, okay, or 100. It will be more, no problem. So we'll compare the time, how much time it will take for this. Also here it's really quite stress testing, because you see here there are a lot of this function will be called many times. So many 10,000s will be sent, will be incremented quickly in asynchronous way. So I'm trying this in my virtual environment, virtual machine. So virtual machine is working, there's no problem, but sometimes also the window manager is going down and coming back. But these applications are working, I checked. And also there is no data race or something, there's no problem. But also I put here the log guard, okay, mutex, but it doesn't matter. It does not affect much the time. Okay, but you can remove it. But I just want to put there to, you know, to get rid of the data race, let's say. This is the first code. In the first part, we write this code. You can find it. I also write this, all the result to the file before to see if there's any, you know, missing numbers, or if there is any dropping stuff. There's none. Yeah, as it's expected. I just checked. Go back, and this will be. I'm using a time tool to measure time, how much time it will take. So Websocket. This will Websocket example. For the same thing, we will use the example we just write here. We will use the same example, same test case. This will, of course, I have to remove this stdc out to be sure. It will get the data and print it out. Of course, I am not going to use the more than one thread. I just want to use, you know, one single thread. So that is why I want to remove this command here, and also this one. So I'm testing now single thread asynchronous operation against a synchronous operation with throwing a thread to handle more, you know, more than one client. It's quite nice test. Okay, with the Python script, which will increment the data such as integer and send it to the our server using the, I don't know, 10 or 1, 2, 3, 4, 5, 6, whatever, some bunch of with functions. Let's run the Websocket example and run it. But yeah, I forget to remove the print. Example, clear it. Okay, let's see. It took around 4 minutes as a user, 3 minutes something. So let's try with our example. Now with this, let me compile first. Let's run the example Websocket async, and let's run the Python script to test. But I forget to remove this thread ID stuff. Thread ID. Is there any? Okay, as you see that connection is also accepted. That we have to also remove this. Connection accepted. So let's run the Websocket example here, then Python script. Let's wait. So as you see, this is 3 minutes. And for the user, 2 minutes, 29 seconds. So this is for 10,000 data. If you increase the number of data, I will share the scripts also, you can try. You can see the difference more. For example, let's increase the number here. 100,000, whatever. Then, you know, for each function will be called asynchronously here in the Python. Then we increment the x from the 0 starts 0 to 100,000. Then it will send an echo, you know, get it back. So let's try again with the async, our Websocket async example. Then we can try with the our normal client, normal Synchronous one. This will take much time. Yeah, then I am going to pause the recording now. So it took around 30 minutes, 33 minutes, as you see here. As a real. So yeah, let's try with the our Synchronous version with the Websocket example, with the same Python script with which sends 100,000 with the number of functions, you know. Let's try with the synchronous and let's see the difference. Test has finished. So as you see, it took 44 minutes for the synchronous test case. As you see, if you increase the data number or task, then you can see the difference more clearly. But I'm not sure this is a good idea, this is a good way to test. In the next, if I found something more clear or better to, you know, which shows a better test case, which shows the difference clearly between the synchronous and asynchronous operations, then I will share also. But also here, we can see the difference. We can see that asynchronous operations are far away faster for, you know, if you have more data, more tasks to handle. Also, we can check also the memory usage. As you expect in the synchronous version, we are throwing threads, which is not a good idea for the memory usage. But I'm not showing this here. This is the end of the content. I hope you enjoyed. As a result, we learned what is the difference between the synchronous operations and asynchronous operations. We write a simple example with the echo server. We understand how we can use the async accept or async methods APIs from the Boost with the Websocket also. And we just, you know, compare with some simple Python with the Python script. And yeah, that is it. Thank you for watching. See you again. Probably in the next, part 3, I will create a content about the HTTP operations, but I haven't decided yet. I will check.